Back in the late 1980s, the UK underwent a bit of a revolution with regards to its approach to health and safety. And indeed, by the early 90s, the legislation which affects us today was all in place and augmenting the well-established Health and Safety at Work Act 1974. Electrical safety was one of the topics that became the focus of its own set of safety regulations. In this case, the Electricity at Work regulations, which were published in 1989 and came into force in April of 1990. Like all safety regulations, they cover 4 main safety issues, and this video will help you to become conversant with these. Organisations should implement their own electrical standards, maintenance strategies, competency management systems and safe systems of work to ensure that they meet their statutory obligations. But it is important to realise that any company documents can only supplement the Electricity at Work regulations and cannot cancel or nullify any of the obligations and duties on management, employees and contractors contained in them. At first glance, it would be easy to gloss over the first 3 regulations, since they appear to be administrative, but they do actually contain important information. The first can be dealt with swiftly, since it simply states that the regulations are the Electricity at Work regulations, which came into force on the 1st of April 1990. Regulation 2, headed Interpretation, gives the special meaning for 6 terms used in the regulations. It's important that you understand the meaning of these terms. Let's start with danger, defined as risk of injury. It's arguably the most important word used in the regulations, where the emphasis is on the avoidance of danger, that is to say, avoidance of risk of injury, and not the avoidance of injury itself. So where in Regulation 5 it states that no equipment may be put into use where its strength and capability may be exceeded in such a way as may give rise to danger, the risk of injury which may be created by poor design or a lack of due diligence at the commissioning stage, for example by not undertaking initial verification in compliance with IET wiring regulations, would constitute a breach of the law even if no injury resulted. So, whenever you read a regulation with the word danger, replacing it with risk of injury may help you understand where the intention lies. Injury itself means death or personal injury from electric shock, electric burn, electrical explosion or arcing, or from fire or explosion initiated by electrical energy, where any such death or injury is associated with the generation, provision, transmission, transformation, rectification, conversion, conduction, distribution, control, storage, measurement or use of electrical energy. Let's take a moment to check your understanding of electric shock and burns. At the standard supply voltage of 230 volts AC, the threshold of perception of electricity is roughly the same current as needed to charge most smartphones, about 5 milliamps. Here you will generally react as if you touch something hot. Increasing the current to about 10 milliamps, however, may mean you can no longer let go, the 50 Hz supply swamping the nerve impulses between brain and muscle. Once electricity has you in its grip, it will not let you go. Once the current reaches the order of 30 to 40 milliamps, chest paralysis becomes a significant problem, preventing you breathing. So it only takes about 7 watts of power to kill you. At about 70 to 90 milliamps, ventricular fibrillation occurs. That's a power of between 16 and 21 watts, which isn't even enough to charge most laptop computers. There are two types of electrical burn: contact burns and flash burns. Contact burns arise when the person receiving a shock cannot let go of the conductors, and the conductors literally burn through the flesh. Such burns take a long time to heal and can be quite devastating. Flash burns come about when a fault current is released, as will happen when a short circuit occurs. It's important to understand that although not every shock is lethal, every shock is of great importance, because what may be a trivial experience for one person may be a fatal experience for the next. All electric shocks, therefore, must be reported, as must all electric burns. It's important to distinguish between a conductor and a circuit conductor. A conductor is anything that will conduct electricity. It need not be a metal. It may be a liquid, such as the electrolyte of a battery, or a gas, such as in a neon sign. A circuit conductor, under normal conditions of use, is intended to carry current, as with the line and neutral of an electrical circuit. However, a protective conductor is not considered a circuit conductor under the regulations. Electrical equipment under the regulations includes everything from a piece of flex to an overhead supply line, a small battery to a large generator. The regulations are all-inclusive. It may be worth mentioning at this point that although the electricity at work regulations apply to all electrical equipment, the IET regulations do not. They only apply to electrical installations. Machinery, for example, has its own electrical standard, EN 60204. Please refer to our video on the safety of machinery for more details. A system means an electrical system in which all the electrical equipment is, or may be, electrically connected to a common source of energy, and it includes the source and the equipment. It's important to note that equipment does not have to be connected to be part of a system, if the possibility of connection in the future still exists. For example, equipment which has been isolated is still part of a system. Also, when ordering equipment, the intention must be to connect it to the system. It is important, therefore, that all equipment is ordered with the full knowledge of the local duty holder. A system does not have to be fixed. It may consist of a portable generator or form part of a mobile machine, such as this forklift truck. If equipment is disused, the best way to deal with it is to remove it, so that it is clearly no longer part of the system. Other terms which are not defined in Regulation 2, such as live, charged or dead, keep their normal meaning. For a conductor to be live, it has acquired a potential by being connected to a source of electricity. Live conductors are also charged, but conductors may acquire an induced charge without being made live, as with this road tanker offloading sugar. Equipment which is dead is neither live nor charged, and for equipment to be isolated, it's been made dead in such a way that it cannot inadvertently become live or charged. Regulation 12 defines what's meant by isolation, a subject we'll be saying more about when we look at that regulation. In this section, we'll look at the difference between regulations which are absolute and those which contain the phrase "so far as is reasonably practicable." And remember, demonstrating compliance with regulations containing these terms could become necessary in a court of law. As you read through the regulations, you will notice the phrase "so far as is reasonably practicable" in Regulations 4, 6, 7 and 12. In current health and safety practice, you will often hear this referred to as the ALARP principle. When this term is used, the duty holder must assess and balance the danger against the cost, time and effort involved in removing that danger. If the risk is small but the cost is large, it may not be reasonably practicable to remove it. However, where the cost is small but the risk is large, then you would expect the regulation to be met, and the level of duty to prevent danger approaches that of an absolute duty. In the remainder of the regulations, the duty to comply is absolute. That is to say, the requirements of the regulations must be met, regardless of time, cost, and effort involved. However, the absolute requirements of the regulations are subject to the defence outlined in Regulation 29. In order to use this defence, it must be possible to show that all reasonable steps were taken and all due diligence exercised to avoid committing an offence, which can be difficult once an offence has actually been committed. Let's now turn our attention to the regulations which deal with duties imposed under the regulations and the issue of competence, Regulations 3 and 16. Regulation 3 imposes duties on both employers and employees to comply with the regulations insofar as they relate to matters under their control. Employees also have a duty to cooperate with their employers in complying with the regulations, but what is meant by matters under their control? For employers, this is relatively straightforward. It would normally mean that they're responsible for any electrical equipment, systems or installation under their control. In order to discharge their duty, employers would normally appoint electrically competent people, or duty holders, to be responsible for all parts of the electrical systems on their sites. Of course, this does not absolve employers from their responsibilities, but enables those with the appropriate competence in electrical matters to manage the electrical systems safely and advise employers accordingly. For employees, matters which are within their control is defined by the individual's electrical competence. However, even employees with little or no competence in electrical matters still have a responsibility under the regulations. For example, a financial director has a responsibility to ensure adequate funding is available to allow compliance with the regulations. A production manager has a responsibility for allowing equipment to be maintained in accordance with the regulations. And any employee not authorised to carry out electrical work must still be able to carry out a visual check on a piece of portable equipment which they're planning to use, or report a faulty piece of equipment such as this fluorescent fitting. Regulation 16 deals with the issue of competence. In order to carry out electrical work, a person must be in possession of the necessary knowledge or experience to prevent danger and injury, or be under appropriate supervision. There is a very similar definition in the IET wiring regulations. This was introduced with the 17th edition. In practice, this would mean having the tasks individuals have to carry out listed together with the training necessary to carry out those tasks, and a training program in place to ensure that the person concerned had the right knowledge or experience. Knowledge or experience boil down to firstly formal or academic knowledge, such as a BTEC national or degree. Secondly, on-the-job training and experience supporting formal knowledge, such as an NVQ or industrial training to gain chartered status. And thirdly, local knowledge, which doesn't relate so much to the individual's knowledge about the plant and equipment, but more to having appropriate safety management systems, such as up-to-date drawings and a well-labelled installation, coupled with electrical safety procedures and electrical standards for equipment. And finally, knowledge of the assessment of risk. An authorisation procedure should be in place, such as the issuing of authorisation certificates, which list the tasks or gives details concerning an employee's level of competence. In this way, both the company and the individual know what the matters under an employee's control may be. Well, we seem to have covered quite a lot so far, and yet we still haven't reached the core of the regulations. Just before we do, you may be wondering why we haven't mentioned regulations 17 to 28. Well, this is because these relate to mines and quarries, so won't be covered in this video. Also, there are regulations 30 to 33, which deal with exemption certificates, extensions outside Great Britain, disapplication of duties, and revocations and modifications respectively. We shan't be covering those either, perhaps something of a relief. Well, that leaves regulations 4 to 15 inclusive. So let's begin with what you might call a catch-all regulation, Regulation 4. Regulation 4 covers design, construction, maintenance and work activities on electrical systems, and also personal protective equipment. It is general in its application and lays down in broad terms the more specific requirements set out in Regulations 5 to 16. Ironically, considering it doesn't contain the word maintenance in its title, it has been the maintenance requirements of this regulation which have possibly had the widest impact on every workplace in the UK, launching as it did the requirement for inspection and test in general and portable appliance testing in particular. This requirement for portable appliance testing, or PAT testing as it's affectionately known, has been further emphasised by Regulation 6 of the Provision and Use of Work Equipment Regulations, which requires employers to carry out inspections on work equipment. Part 1 of Regulation 4 requires that all systems shall at all times be of such construction as to prevent danger. Construction of a system covers the design, arrangement, assembly or installation and the physical condition. Moreover, the time factor at all times means that the regulation applies not only while the system is in normal operation, but also during any testing, commissioning and maintenance, and also if a fault occurs on the system. Safety begins at the design stage, where knowledge of prospective fault currents and how to calculate them is particularly important in determining what protection is required. But a good design should also take into account how the system is to be maintained, the environment in which it's to be used, and what the duty cycle may be. As we mentioned, you may already be aware of some of the requirements of this part of Regulation 4 because of PAT testing. Part 2 requires that all systems are maintained so as to prevent danger, and is the only part of the whole Electricity at Work regulations which mentions maintenance. So maintenance requirements are a very broad brush in the regulations, but there is plenty of guidance available from the HSE and British standards, as well as manufacturers' own recommendations. There is a duty on employers to provide safe systems of work for all work activities. Important inclusions for electrical work would be an isolation procedure and a procedure for working on or near live conductors, such as when carrying out inspection and test. We'll be saying more about these when we talk about Regulations 13 and 14, but effective, safe systems of work are also important for compliance with Part 3 of Regulation 4. Regulation 4 Part 3 relates to work activities and requires that operation, use and maintenance of a system and work near a system is carried out so as not to give rise to danger. Bear in mind here that work near a system may not be electrical work. This part of Regulation 4 is supported by Regulations 13 to 16 inclusive. The last part of Regulation 4 is absolute and requires that all personal protective equipment provided for use is suitable for the task, maintained in good working order and properly used. So employees have an absolute duty to use protective equipment which has been provided for their use.